So what we're starting today is chapter 2. Today's going to be the start of chapter 2. Now, everything in chapter 2 is going to be revolving around reasoning and proofs. This is going to be the only section where you're going to actually have to work proofs out. And we'll go through them together and work through. And again, it's all problem solving and reasoning. Thank you. Tennis coach got them for me when I was still playing.
What? New hair every day.
Yeah. But we're going to work through these reasoning proofs together. Some of the first examples of proofs that we'll do are going to go back to our linear equations. So solving, well, I get the pen. Problems like this here, solving this out and explaining each step why we can do what we can do. So using the substitution property of equality, being able to subtract 7 from both sides. So our first main step if we were solving this is to subtract 7 from both sides, yes? Well, the reason we can do that is our subtraction property of equality. And we will go through and do proofs with these here, solving these linear equations, ones that we've done before, and then build into the geometric proofs. A little bit, yes, but we won't get there yet. What we're looking at first is a conditional statement. And y'all looked up the definition of this yesterday. Now, a conditional statement is a logical statement in two parts, a hypothesis, P, and a conclusion, Q. When a conditional statement is written in if-then form, if part contains the hypothesis and the then part contains the conclusion. Y'all can write this out, but I believe you also wrote this out yesterday, yes? Because if we're talking about a conditional statement, we write it in if-then form. If the hypothesis, then the conclusion. And in symbols, we have it as this here, if, then Q. P implies Q. Is a conditional statement. Questions on this so far? So let's look at our first one here. So use red and blue to identify the hypothesis and then conclusion, then rewrite the additional statement in if-then form. So we can underline the hypothesis. So looking at this here, all birds have feathers. So our hypothesis is, well, kind of all birds. Our birds are our hypothesis. Yes. And the conclusion is have feathers. Mm-hmm. So mainly we're talking about if then. The hypothesis, we're talking about birds. If it's a bird, then what? So if then form, if it is a bird, then it has still taking a while. And that's it. Questions on this here? Yes.
Wait, is it going to get harder?
Here and there.
Oh, what the heck?
We ready for the next one? Make sure. So, you are in Texas if you are in Houston. So what's the hypothesis for this one here? So hypothesis, if you're in Houston. And the conclusion is? Mm-hmm. So this here, we just rewrote it. Well, since we're going to be using text the whole time, might as well use this pen. If you are in Houston, then you are in Texas. Yep.
Okay, I just have to ask, what does this have to
Because again, with all math is just using proofs and logic and reasoning. Because if you boil math down to its basic essence, it is all logic. Logic and proofs.
So,
Yeah.
okay.
Questions on this here? We good with this here? Now, some of them will have to rearrange or kind of rephrase it a little bit to make it work a little better. So this one here, all 30-degree angles are acute angles. So our hypothesis, what are we talking about?
The 30-degree angles would be the if, and then it's just
Yep. So, well, it's,
if it's a 30-degree angle, then it's
yes. 30-degree angles are acute angles. And one of the big ones, especially when we look at if it's an if-then form, if is going to be in front of the hypothesis, then is going to be in front of the conclusion. If and then are not a part of the hypothesis or conclusion. They kind of say that it's coming up. So if it is a 30-degree angle, then it is an acute angle. See how it does with this? And that's it. Questions on this here? Are you ready for the next one? Yes? 2x plus 7 equals 1 because x is equal to negative 3. So our hypothesis.
Is 2x plus 7. What am I?
if x is equal to -3, then 2x plus 7
No. If this, then, yep. So if 2x plus 7 equals 1, then x equals negative 3. If this is true, then this is true. If this is true, then this follows. If 2x plus 7 equals 1, then x is equal to negative 3. That's the value of x. Now, if we had it the other way, if x equals negative 3, then 2x plus 7 equals 1. Is that true? Well, yes. But could other equations work for x equals negative 3? Yeah. Because really being able to write the sentence helps us be able to show the proof. And we'll get into showing or explaining how we can know if something is true or not. Because when we get into later part of this chapter, all we need is one example to prove something's false. For a counterexample, x is greater than 5 if x is greater than 3. So our hypothesis. So if x is greater than 3, then x is greater than 5. And this here is really the foundation to all proofs. Anything that we do, the Pythagorean theorem, proving that it's true, really starts at this here. If we had it the other way, yes. Because whenever we prove something, we start with this here. We assume that this is true. And then can we see, based off of this, can we say that this is false? And yes, that's an example x could be 4. But the other way is true as well. So we don't like this. Well, if we did it the other way, if x is greater than 5, then that's true. We could switch it around that the hypothesis works better if x is greater than 5. I do like this one better than that one. But at this here, if then, hypothesis conclusion. We good with this here? All members of the soccer team have practice today. So how can we rewrite this in if-then form? Yes. If you are a part of the soccer team, then you have that's it. Questions on this here? Any question on anything we've done so far? We ready for the next part? Negations. Okay. We ready for negations? The negation of a statement is the opposite of the original statement. The negation of the statement is the opposite of the original statement. So we can write it with this here. So it's the negation, or we say not P. So if we have that little swiggle, it's saying not P, okay? So let's see here.
The ball is not red.
No, so the negation of it, not P. So we would say that the statement here, the ball is red, is our P.
Does it really matter if like we do like the like it's in instead of this one?
That's fine. Yes.
I'm just gonna get you out of
That's it. We just negated. It's the opposite of the statement. So the ball is red. So the negation of it, the ball is not red. The cat is not black. So the cat is black. That's it. Questions on this here?
car is not white.
Almost. The is not. Car is not white.
It is snow.
Taylor, I thought you were literally saying it was snowing, and I was
What about it? What about the ball is red?
Huh?
Ball is red.
The negation is. The ball is. Yeah.
I like how we normalized it. Like,
Because
The shirt is not red.
so these here. So the shirt is green. The negation is. The shirt is not green. So the shoes are not red. Its negation is the shoes are red. And that's it.
So is there like no true math in this today? It's all just
Well, this is 100% math. We're just redoing it. Math has 100% words.
There's no computing that needs to be done in
Yeah.
math is all
Yeah. 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 No, I was just looking at this. Because, I mean, realistically, when we get into a lot of the proof-based math, the amount of actual numbers.
very significant.
Yep.
the title of that. Elementary and what is it?
Proof
Like for
of calculus.
vocabulary negation.
It's proof-based calculus. But, so are we good with these here? So, guys, last thing we're talking about relating conditions. So, the first one we have is the converse. Converse. To write the converse of a conditional statement, exchange the hypothesis and conclusion.
So we're switching them around.
So for our conditional statement, we have if P, then Q. So if the hypothesis, then the conclusion.
So then it would be then P,
So converse, if Q, then P.
then Q.
So conditional statement, P implies Q. So our first one, P implies Q, is our conditional. Our converse, Q implies P. So we switch it. We switch the hypothesis and conclusion for the converse. We good with this so far? Is anybody still writing? The next one we have is the inverse. To write the inverse, we write the conditional statement, but we negate both.
That is a lot of words.
So our original statement, but we negate both.
These are all on our code that we do this.
Yes. And the contrapositive is we just flip the inverse. Now, if we can say it's true or false, the conditional statement and its contrapositive, either both going to be true or both false. If the inverse and converse are true, so these are both going to have the same truth values, and these two here. Conditional and contrapositive, if one of those is true, the other is true. If one of those is false, the other one's going to be false. If the converse is true, then the inverse is true. If the converse is false, then the inverse is false. They stick together. Now, a lot of words there, but we're going to go on and write this out because we're going to see one of these worked out here, okay? So, let P be you are a guitar player, and let Q be you are a musician. We're going to write these out and determine whether they're true or false.
If you are a musician.
So, if, almost,
Go
If you are, yeah, that, you are a guitar player. I don't know what I'm doing.
so P is you are a guitar player, yes? So our conditional statement, our first one, if you are a guitar player, then you are a musician. Because we need the if and then. Because I will count all points if you drop the if or then. We can put a comma, yes?
That's what I did. I forgot to put converse.
But you do need the if and the then. You need the if and the then. If you just write if you are a guitar player, you are a musician, I will count all points. You need the if then. Questions on this here? Now the converse, we're flipping the hypothesis and conclusion.
So then it'd be the other way around for a musician if you were a musician.
If you are a musician,
Okay, well at least I got converse right. Makes sense in my mind.
then you are a guitar player.
Mr. McClendon, you better be
Question on this here for our conditional and our converse. Now we're looking at the
inverse.
inverse. Inverse is the negation.
If you're not
musician.
If you are not a guitar player, then you are not a musician. Yeah, you can use that. What? I'm not going to be nitpicky on grammar because some of these get really funky. Huh? I will at least want you to give me the full word. So any question on conditional, converse, or inverse? So contrapositive, if you're not a musician. Then you are not a guitar player. So question on these four here. So now we're going to say whether they're true or false. So if you're a guitar player, then you are a musician. Is that true? That's true. We can say that's true. How about the second one? If you're a musician, then you're a guitar player. You can play other instruments besides the guitar, so that's false.
So wait, do we have to say whether they're true or false?
If it asks for it, yes. Mm-hmm. If you're not a guitar player, then you're not a musician. Exactly the same reason we said the second one was false. And the last one, if you're not a musician, then you're not. Yeah. Because if you don't play if you're not a musician, you don't play anything. Yep. But as we said a minute ago, if the conditional statement's true, the contrapositive should be true as well. If the converse is true, the inverse is true, or vice versa. Because if the conditional statement's false, the contrapositive is going to be false. If the converse is false, the inverse will be false. Questions on these here? Do we need to see another one of these? Because that's all the rest of these are, is just rewriting these. Yep. That's it, really. Yep. It is. Nope, I have it right here. Then turn it in. So it's just a whole bunch of writing, really. Yeah. You'll have to ask my wife that one, because she's the one that got it for me. What's that? Huh? It is hockey players. Yes. The Nashville Predators. Visual sheets. No. It's not over here. Nope, that's all part of that. Yeah. Two. Heck. Yep. Yeah. Right here. It's 3 through 6 all, 8 through 22 even. Yes.
Oh man.
I mean, otherwise you could do it virtually.
This is
No.
Pull up the digital textbook and do it that way.
Now write on your board real fast.
Possibly.